Hello all. In this video, I would like to talk about a different property of transfer functions, poles and zeros. Probably most of your exams, in control exams, you will get asked to find poles and zeros of a system, of a transfer function. So I will break it down so that you can understand better what a pole and zero actually is. So first, in the previous video, we talked about something like Hs equals Cs over Rs. This was simple. At the top, we called this part the numerator, and at the bottom, we call this denominator. Again, to repeat it, Cs stands for the output function, Rs stands for the input function. And if you wonder what a zero and a pole is, I just give it directly to you. A zero are some values or some roots that make Cs go to zero, since it may lead our Hs go to zero. With a similar manner, a pole is a value that makes our Rs go to zero and makes our Hs reach out to infinity, because a certain value divided by zero is going to be infinity in theory. If you want to memorize the difference, since 0 makes our Hs go to 0, it is 0. Since a pole doesn't make us Hs go to 0, it's pole. It leads us to infinity. So let's make a simple question to make you understand the whole issue. So let's say you're given a transfer function with Gs equals s minus 4 over s plus 3 times s plus 1. So let's find out the zeros or pole and poles of the system. So if I get to ask you to find the zero, you will take a look at the numerator part. We have s minus 4. So it's so easy. What makes s minus 4? It's 4. So our zero is 4. Take a closer look at now for pole or poles. We have two different parentheses here. So one is s plus 3 and the other is s plus 1. So if I ask you find these roots of this polynomial, you will get to say easily p1 is minus 3 and p2 is minus 1. And sometimes we'll get asked to draw them in a map, and it is so easy. Let's draw a map. But keep in mind, by drawing this map, you should know that a value can be written as in the form of a plus or minus bi. So this bi part is the imaginary part, and this a part is a real part. So we will denote our x-axis as real and y-axis as imaginary, right? And to indicate your values, poles and zeros, so let's see, our 0 is at 4. So if here is 4, we can say this is a 4 and there is circle, which indicates our 0. For poles, we will go to the other side, the left-hand side of this map, and we will say, let's say here is minus 1 and this is minus 3. To indicate your poles, you just cross and indicate that are those zeros. That is this easy. But not always those questions will be this easy. So let's do one more example and see an upper level of questions. So we will have our Hs equals s minus 2 over s squared plus 4s plus 4. Again, 0 is so simple to find. What makes s minus 2 0? Our 0 is 2. But for poles, I cannot directly find like a certain value makes this function 0. So I can think or memorize some high school information. So this 4 and this 4 means something to me. So this 4 says p1 plus p2 is actually 4, and the other one says p1 times p2 is actually 4. I can think of only one value that satisfies these two conditions, and we have two poles, and surprisingly these two poles are the same. P1 and P2 are both 2. Do not get confused. Maybe in future you will have 3 or 4 poles at the same point. This is so normal. this affects the system in a different way, but we will cover those topics in later videos. But for just now, don't get surprised when you see 2, 3, 4, 5 poles in the same point. And maybe the I think the most difficult one you will see during the exams when you have this kind of function. So let's write it down. GS equals S plus 4 over S squared plus S plus, let's say, 1. So again, 0 is simple. We have a 0 at minus 4. But when you take a look at the denominator part, as I cannot find a certain value, or I can't think of a combination of values that makes plus 1. The summation is 1, multiplication is 1. So maybe I should apply a formula here. So since you all know from high school, there is a thing called the delta, right? We can find, if it's a second degree equation, we can find our roots of this corresponding system or function with this way. Let me draw it down. So the roots, let's say R1 and R2, are minus b plus and minus square root of delta over 2. And delta is b squared minus 4ac. b is 1, s is 1, and c is 1. So let's find our delta. 1 minus 4 times 1 times 1. It is minus 3, right? And to break it down into finding the roots, we will see, let's say, R1, R2. So we will have minus 1 plus or minus square root of minus 3 over 2. But leaving this square root inside, there's a minus. It's not valid in terms of mathematics. So we need to do a conversion here. So since you guys all know I equals square root of minus 1, we can say this square root of minus 3 equals I times square root of 3. So if you get I inside, you will have this value. I think that's kind of simple to understand, but if you get to write poles in the correct way, you should do a separation. So let's say first pole is minus 1 plus I square root of 3 over 2. And the second one is pole 2 is minus 1 minus I times square root of 3 over 2. So let's break it down into this map, what we had in previous example. So we have a map here. Oops, it's so bad. And yeah, we have the other axis. Right, this is real axis and this is our imaginary axis. So minus 4, we had R0. So if it's here minus 4, we have a 0 here, indicate with a circle. And let's switch back to red. So we have, so P1 is actually a combination of two different values, minus 1 over 2 plus I times square root of 3 over 2. So we can see this is the real part and this is the imaginary part. So for real part, also let's write it down for P2. So we have minus 1 over 2 minus I times square root of 3 over 2. So we will have something here. So let's say here is 1 minus 1 over 2. And let's say this square root of 3 over 2 is a value roughly here, okay? Square root of 3 over 2. And the other one will be minus, they are symmetric, minus square root of 3 over 2. So this is a combination of two different values. So if you want to point the exact point of your, let's say, pole, you will draw some dotted lines for each axis and combine them onto a certain place. And again, for the other one, just keep in mind those are symmetric values. The other one is going to be here. So this is how you find your poles and zeros and map them into a certain, let's say, coordinate. And I hope this video overall was helpful to you. And maybe upcoming videos we will do some responses and etc., the advanced, let's say, topics rather than those basic introduction courses. And I hope this video was helpful and enjoyable, and hoping to see you again in the next videos, and catch you later, and goodbye.